In spring of 2026, our team of Penn State Engineering students was sponsored by Technical Manufacturing Corporation to develop an automated test bench for the PEPS-2 controller. TMC is an engineering company that specializes in vibration control and makes test bench systems for clients in industries like semiconductor manufacturing and life sciences. They required a reliable way to test controllers before deployment to customers. Our team focused on designing a test setup and software to verify multiple functions of the controller, then generate a comprehensive PDF test report showing the results.
Now to briefly cover the electrical side of the project, we created a virtual test bench using LabVIEW, which is composed of a main VI that controls all sub-VIs and runs them all at the same time. The sub-VIs consist of data acquisition and input conversion to outputs. We get the raw input data using analog circuitry and an Arduino. From there, we take the output and are able to list it into a PDF.
Here's where we stand today. Our final prototype is built and operational. On the left, you can see our LabVIEW test bench controller interface, which monitors pressure sensors, valve currents, proximity sensor locations, and live status indicators across all 4 isolator tanks simultaneously. On the right, that's the physical setup. Air compressor, pressure transducers, tanks simulating real isolators, and our Arduino breadboard all wired and running.
Here's the physical test bench we built for the PEPS-2 controller. On the left is the air compressor, which feeds air through a filter and regulator to pressurize the air tanks. The 4 tanks on the right simulate the isolators used in the real TMC setup. Each tank is monitored by its own pressure transducer, which records real-time pressure readings. The 3 proximity sensors are mounted on custom fixtures and positioned to test the accuracy and repeatability of the controller. The Arduino and breadboard handle the diode verification circuitry, and all of this information feeds into our LabVIEW software.
So right now you're looking at a front panel in LabVIEW of our project. To start this, you click the arrow in the top left corner, then you click Start. Right now, LabVIEW is compiling all of our data that we have acquired from pressure transducer readings that are being stored into an Excel file. Once those Excel files are done, we click Stop, and then now we will generate 4 PDFs for each valve we took measurements on. And then once those PDFs are done being generated, they are saved along with the Excel files into our project folder where all of our LabVIEW code is, and we have a separate folder for the PDFs and Excel files.